Well, in the last video, I talked about how to set up a fully interactive model that produces separate intercepts and separate slope coefficients for each value categories of indicator variables. In this case, it would be provinces, right? And people might still have complaints. They say, well, I want to do it myself. I want to have full control over this process. So what I'm going to do is I'm going to run regression for each province. I'm going to collect all those coefficients and standard errors. I want to know what's exactly going on. And this is what we're going to do. And there are different ways to do it. For example, one can use some packages of this mega package tidyverse to do it automatically. But, I'm a pretty, rough quantor. I want to do it myself. I want to set up as a loop. So here is how we're going to do it. So here, we're going to turn this province name. This is a character variable. First of all, we're going to turn into a factor variable. So we use as factor here first to turn it into a factor variable temporarily. Why am I going to do that? Because I want to use this levels function to extract all the values from this province. So I can do it for you, right? So, and I can show you what's in that extracted object, right? You see that? It extracts all the unique value categories of this variable province. And also another piece of information is useful is I want to figure out how many unique value categories there are, because I want to do the loop. To set up the loop, how to figure out, how many iterations I'm going to go through, right? So I click it, and it should be equal to 28. We can see if it's 28. Yeah, it is 28. The next thing I want to do is, if you recall, I want to collect all these intercepts and slopes by myself. So what I'm going to do is I'm going to create an empty matrix with the same dimension. So its row is equal to G, which we just calculated, which is equal to 28. And column is 2. Why do we need to have column set to 2? Well, one column is for the intercept, one column is for the slopes. Of course, we can set up more columns, right? For the standard errors, for the p-values, whatever. You can do that, explore by yourself. Next one is the workhorse of this, job, right? What I'm going to do is I'm going to run through every single province, run a regression, and relay the information about the intercept and slope to the matrix. So here is for loop. For this I from 1 to the length of left string. What is length of left string? So basically, it's asking, how many iterations we're going to go through. So how many provinces we have. Actually, we've already calculated. I could have replaced length of this one equal to G, right? But to show the full picture, still here I'm using, from 1 to the length of left string. What is length of left string here? Well, if you recall, it's 28, right? So basically, it tells R that I'm going to run through 28 because that's the length of, left string. And what is the length of left string? Well, that's actually the number of provinces there are. 1 to 28, 28 iterations. So I'm going to assign left string I. So I varies with each iteration. In the first iteration, it is 1. The second is 2. So the left of string 1 in the first iteration is what? Is equal to curve prov, that is current province. So what is left string I? Well, it varies, right? But let's see what could it be equal to. So let's say left string 1. What is equal to? Equal to Anhui, right? It's equal to Anhui. What about left string 2, if you recall? String 2 is Beijing. Okay, Beijing. So it varies, right? Then also, the second line here is that I select a subsample, because if you recall, I'm going to run a regression across every single province. So what I'm going to do here actually is I'm selecting cases. If we're talking about the first iteration, I'm selecting cases from the first province, which is Anhui here, right? Because left string 1 is equal to Anhui and prov name equal to Anhui. Okay, so this statement, if we're talking about the first iteration, it only selects cases from Anhui province. Okay, then I run my regression while the dependent variable, independent variable with intercept. Okay, data equal to curd D. Okay, in this case, in the first iteration, it is Anhui. Then I update this matrix, this empty matrix. So I don't care about how many, which row we're talking about. Actually, in the first iteration is the first row, right? Anhui. First column, okay, is equal to coefficient MyLM 1. That is the intercept. Okay, so replace, if we're talking about first iteration, the element 1, 1 with the element of the coefficient for my LM 1. That is intercept. For the second column, again, the first row, we're replacing it with the coefficient for the slope. Okay. Then, I use this cat, function to display which province we're talking about. Okay. Then is to print the output. Then we go to the second iteration. The second iteration is for Beijing. So I here, all going to be replaced actually, by information related to Beijing. And third and fourth until we hit 28. 28. Okay. Once we hit 28, okay, we've replaced every single element in the comat, that is this matrix. Okay. Let's run through. Okay. And we can look at this matrix. See that? So it has a dimension of 28 by 2. The first column provides all the intercepts, and the second column provides all the slopes. Okay? And for the first row, it is about Anhui. For the second row, it is about Beijing. Okay? And we can compare the output here with, the results produced from the previous video, right? Using the fully interactive model. But for every single province, intercept and slope, without doing any additional computation. Well, the only thing that differs between this set of results and last set of results, okay, so this set of results here, right, and last set of results here would be, well, the estimates are exactly the same for the parameters, that is slopes, intercepts. The standard errors, well, if we use a single equation, in a single regression equation, the standard error is going to be smaller. The obvious reason is because we use large sample size, right? And here, results from here, you can check through, okay, for, the standard errors of each parameter estimate. They're greater than those produced from the single equation, because obviously the n is what? Smaller. And so here, I just show you how to, loop through the value category of the indicator variable to do the same equation, right? That is, regression of income on education by province. Okay, well, then we use this loop to collect all the information and move on from there.